Welcome back to the channel Stellar Physics. Let's learn about work. Consider a constant force F acting on an object of mass m, moving the object from position A to position B. In this process, the object undergoes a displacement d in the direction of the force. If we define work done, it is the product of the component of force in the direction of the displacement and the magnitude of the displacement. Mathematically, we can write it as W equal to F cos theta into D, which is equal to F dot D vectors. Here theta is the angle between the force applied and the displacement made. Quickly, one would be able to make a few conclusions. If you are smart, you would have understood that no work would be done under three circumstances: when there is no displacement, when there is no force applied, and when the force and displacement are mutually perpendicular, or when the angle theta is 90 degrees, because cos 90 is 0. Let's also add a few examples for zero work. If we try to lift an object vertically at a constant velocity, the force and displacement are in the same direction and the work done will be 0. If someone pushes against a solid immovable wall, the work done is 0 because there is no displacement. When an object moves in a circle at a constant speed, the net force acting on it is always perpendicular to the direction of motion, making work done 0. If someone walks horizontally with the backpack on their back and not change their vertical position, then the work done against gravity is 0. If an object is sliding along a frictionless surface and if it moves with a constant velocity, then the work done is 0. If you hold a weight at arm's length horizontally and don't move it, the gravitational force is acting downward with no vertical displacement. Hence, no work is done in this situation. Let me add a few more things to make your understanding clear. Yes, we saw work can be 0. I would also like to add that work can be both positive and negative. If theta is between 0 degrees and 90 degrees, cos theta is positive and work done is positive. If theta is between 90 degrees and 180 degrees, cos theta is negative and work done is also negative. This will happen when we have forces like friction, which is negative on the object. Let's quickly identify the relation between work and energy. From the previous equation for work done, which is W equal to F cos theta into D, it's very clear that work done and energy have the same dimensions, which is mL power 2 T power minus 2, and both possess the same unit. So it's time to learn the units of work. The SI unit of work is joule, and 1 joule is equivalent to 1 Newton meter. Sometimes we use alternate units like calorie, which is equal to 4.184 joules, or electron volt, which is approximately equal to 1.602 into 10 power minus 19 joules, and 1 watt hour, which is equal to 3600 joules. Let me add some interesting facts about work. Always, positive work moves an object. Negative work brings an object to rest, similar to the force of resistance of friction. Also, the work done on object A by B is not necessarily equal and opposite to the work done on B by A. This is unlike Newton's third law of motion. We can arrive at the conservation of energy because net work done on an object is equal to the change in its kinetic energy. By now you know there is a directional independence because work is a scalar quantity. Also remind yourselves, zero work doesn't mean zero effort. I would also like to add that engineers use work principles to calculate the efficiency of engines and hence optimize the system. Let's not forget that work can be done during processes like compression and expansion, and so it can be used to describe the transfer of energy. Having learned so much, it's time to summarize. So let's be quick in doing that. Work is done when a force is applied to an object and the object is displaced in the direction of the force. The mathematical representation of work done is F cos theta into D or vector F dot D. Work is absolutely a scalar quantity and its SI unit is joule, and we use it to understand the conservation of energy. According to the work energy theorem, net work done on an object is equal to the change in its kinetic energy. Positive work is done when a force aids the motion and negative work is done when a force opposes the motion. Work done finds applications in fields ranging from engineering and mechanics to thermodynamics and astrophysics. Work is also encountered in numerous daily activities. And finally, we use work principle in science and engineering. Hope your understanding of work was clear. Follow the other videos to learn more.